All right, logarithm functions. Okay, so what is a logarithm?
A logarithm. The thing when you. Exponent.
It's an exponent. It's a type of exponent. It's an inverse of an exponent.
Yeah.
Okay? So basically, let's go through this. A calculator shows that 10 to the 9.2 is about this big number, okay? It's a big number.
It's called the function.
Okay? The exponent 9.2 is called the logarithm. Okay? Okay, the base is 10.
Wait, is it just THN?
Okay? In general, any positive number except 1 can be a base for the logarithms. Any positive number except for 1 can be a base. Okay?
Base 1 would be the number.
So here's the definition. Let b be greater than 0 and not 1. Then y is the logarithm of x to the base b is written like this. You could say y equals log base b x. And that is only true if b to the y equals x. So if I wanted to go from one to the other, this is it in exponential form, this is it in logarithm form. They're the same equation, but one's in log form, one's in exponential form.
So the log just scoots down the...
Depends on what you're trying to do.
Where's the y go?
So y is here, now it's in the exponent.
So can you Mr. Murphy had to think about that, but
All right, a logarithm is often abbreviated as, quote, log. You don't have to write the whole word out. And you can read log bx as, quote, log of x to the base b. The definition essentially says that the log of x to the base b is the exponent of the power of b that equals x. Okay, some examples of this. The log 512 to the base 18. That is just like saying log little 8 512. Okay? Another way of writing that is, and no, you can't do this on your calculator because our logs on our calculator are base 10. On the CAS,
No, you can do it on a phone. Want to see?
this is just like saying 8 to the what power equals 512. So you can ask yourself and think in your head, well, 8 times 8 is 64. Times 8, well, oh, that's 512. So x in this case is 3. Okay? You could also say, oh, this is the same thing as saying 8 and then take, no, never mind.
8 times 8 times 8 times 8.
Right. Okay.
You can do it on like a phone calculator.
Yeah, you can just try it. Go 8 to the second, 8 to the third, 8 to the fourth. Yeah, guess and check for right now because we're not to the point yet. I'm teaching you that soon. Okay. Now, this one is log base 8 of 164. So this is like saying 8 to the what power equals 1 over 64.
Can you do 8 to the negative power?
Yes.
So
negative 1 or 2.
Negative 2. So x in this case is x is negative 2.
Would it be negative? Would it do a fraction? Oh, would that make
It's negative because it's now on the denominator. Okay? Yep.
So what happens if you do negative 1/2?
Then it would be the square root. It would be 1 over the square root of 8. So 8 to the negative 1/2 is 1 over the square root of 8.
Why? Why the square root?
Because 1/2 is a square root. Yep.
So we're taking 8 to the second and then we so the negative basically.
Okay.
Got it, yep.
Okay, so this one, kind of that same thought. This is saying 8 to what number
1 over
Yep. Equals the square, the seventh root of 8. And you're right, x is going to be 1/7.
Oh, because it's
Okay?
I don't know how I do that, just pop it.
Okay? So, we have 3 more right here. I want you guys to try these on your own real quick. And then we'll check. All right, so on the first one, this is the same thing as saying log base 8 of 15. So log to the 8 to the what power equals 512. And that should be actually, I don't know why you put 3 there. It should be a 4. Okay? Right? Oh wait, no, this is I'm on the wrong section, you guys. Down here. It should be 4, I'm sorry. I know. Blonde moment. Okay. So, this one. 4 to the what power equals 2? Yeah, 0.5 or 1/2. Okay? This is the one that's a little tricky. If you can get this 36 down to a base 6, which is the same as saying 6 to the second, then you could take 2 times negative 1.5, which equals negative 3. So x in this case is negative 3.
2 times it?
Yeah, because you can take a power of a power, you're multiplying.
Would you have 6?
Nope.
Oh, I see.
All right, logarithms to the base 10 are the most often used. Therefore, we refer to them as common.
Oh, is that the ln?
No, not yet. Okay.
Okay, thanks.
Common logarithms. They are often written without indicating the base 10. The little 10. So log 10 of 100 is the same as saying just log 100. Okay? And those are the ones that your scientific calculators typically have. Okay? Our society that we live and breathe in right now, United States, we all do everything in base 10. There are other societies in this world that do things in different bases. For a long time, the Chinese, I think, went by base 15 or base 12. I can't remember. So, and Egyptians went by a totally different base as well in ancient days. So,
I have a question. Is it like
okay, find the logarithm of each number to the base 10. So what is 10? What is this logarithm? 2. Yep.
what?
This is like saying 10 to the second. So log of 100 is equal to 2.
So wait, what is the logarithm looking for?
Wait,
You're
is the
finding
other?
10 to the what equals 100.
Yep.
Because you're log base 10.
Oh, 10 to negative 4.
Oh, I need to go.
Okay. So this is saying 10 to the negative 5, right? So then log of this number, I'm not going to rewrite it,
Wait, but
equals negative 5.
you have to count the 0 before
Yeah.
hand?
Yep.
Well, that's stupid.
Okay.
Wait.
1 trillion.
On the test, can we just write log arrow?
Yeah, if it's a big number, yeah. So this one would be 12. How about this one? This one's different.
1.5.
Yes.
Wait,
Yes, because look, this is this is 10 to the first times 10 to the 1/2, correct? So if I were to write that as saying 10 to the 1 plus 1/2, which equals 10 to the 3/2, or 1.5. So in this case, we're talking about 1.5 or 3/2. Okay? Let's look at example 3. Bye.
It's been real.
Solve 10 to the x equals 7 in the nearest thousand. Now you can use your calculators.
wait, is that when you just do like log?
So x in this case is going to be equal to log base 10 of 7. So what does that end up being? 0.845. 14.5. Now notice I'm not even going to bother to put the base 10 there because we already know it's base 10.
Is this where we
Yep.
use the log button?
Yes, now you can use the log button. Okay? All right, now these ones they've already found the answer to it, but we need to find the exponent form of it. So this is like saying x equals 10 to the 2.873. 746.4. Okay, and this one is like saying t equals 10 to the 3.41. 0.4. Good. Okay, this one says evaluate logs base 4 of 8. Okay, so this is how you're going to go about doing that. Y equals log base 4 of 8. And I'm going to change this into my exponential form. So this will be 4 to the power of y equals 8. Okay. Now the key to this is to get both sides in the same base. So I know that I can bring this down to a base 2. And I can do the same thing with the 8. So 4 is what in base 2? 2 to the second, right? The base is this number underneath the exponent, okay? Well, I know that.
Number squared equals 4.
Yeah. Okay. Okay, so now if I'm going to change this to base 2, what is this in base 2? Yep, 2 to the third. Okay? So, when I have a power of a power, I can now write this as 2 to the 2y equals 3. No, you're multiplying when you have a power of power. Okay, so I have 2y and 2 to the third. I can now write this as just 2y equals 3. So y is going to be 1.5. So our final answer is log base 4 of 8 equals 1.5. Yep, try the second one by yourself. See if you can do it, and then we'll check. Okay, so this is now going to be y equals log base 9 of 3. And if I were to put that in exponential form, it would be 9 to the y equals 3. I can put that back into base 3 as 3 to the second to the y equals 3 to the first. And then we can just get rid of our bases and have 2y equals 1, so y is 1/2.